Hello, I am Dr. Badarinarayan, the principal of MS Engineering College. I extend a warm welcome to all of you for a discussion on the transportation problems, finding the basic feasible solutions using the matrix minima method. I have considered here a problem in which I have got 4 warehouses W1, W2, W3, W4 with 250 capacity. I have also considered 6 destinations D1 to D6 with different requirements as shown. The matrix also contains the cost of transportation from source to destination. For example, W1 to D1, the cost of transportation per unit is 9 units. So considering the matrix like this, we search in the matrix minimum method the minimum cost of the entire matrix. So as you look from the table, we have 2 as the minimum cost. So for the 2 as the minimum cost, what we do is now we identify the requirement. So the requirement is 200. Now the availability is 250. So therefore 200 units can be shipped from warehouse W4 to destination point D4. So we write the 200 here. So after writing the 200 here or allocating 200 units from W4 to D4, the requirement at D4 is satisfied. Hence, we cancel D4 column. And the availability at W4 is reduced from 250 to 50. We identify the next minimum cost in the entire matrix. So that happens to be 2 again. So for that cell, that is from W4 to D5, we identify what are the requirements and what are the availabilities. So at W4, we have an availability of 50 units. So therefore, we can transport 50 units from W4 to D5, and so we write 50 units here. And once we write the 50 units here, the entire availability at W4 is exhausted. Therefore, we cancel W4 row. And this 50 gets reduced. That is, we have the requirement of 200. 50 is being satisfied. Therefore, the 200 will become 150. So the next minimum cell is 3. Again, for that, 150 units are shipped from W3 to D5. And the total availability at D5, that is the total requirement at D5, is 200. Therefore, it satisfies 150 plus 50 is 200. So it satisfies the requirement, hence we delete the column D5. Next, we identify what is the minimum cost. So the minimum cost is next is 3. So for that, again, the items has to be moved from W2 to D2. The availability is 250, whereas the requirement is 100. Therefore, we ship from W2 to D2 100 units, such that the requirement at D2 is satisfied. Therefore, we cancel that particular column, and this 250 minus 100, so the availability will be 150. So we identify the next minimum cost. What are the next minimum cost? So the next minimum cost is again 5 here. So for which now from W2 we have an availability of 150 and the requirement is here is 200. So we transport 150 items from W2 to D6. So when you transport 150 units, now out of 200, still a requirement of 50 units will be there. And since we are satisfying the availability at W2, that is 100 plus 150, we cancel this W2 row. Similarly, the next minimum cost cell is 6. So for which we identify what is the requirement. So the requirement is 100 units and the availability is 100 units. So therefore we allot 100 units to be shipped from W3 to D1. So by doing so, the availability at the column, that is D1, is 100 units, and what is available at W3 is also 100 units. Now there is a need for us to cancel both the row as well as column. So at this point, we don't cancel the column, we retain the column by cancelling the row. And for the column, we indicate a value epsilon, that epsilon will be there. We don't simultaneously cancel both the row and column, but we keep the column with a requirement of epsilon unit, where the epsilon is nothing but 0. Now in the next minimum cell, we observe that it is 9. So for the 9, what is the availability? We have 250 units, but the requirement is only epsilon. So we allot epsilon units, that is from W1 to D1, epsilon units are more, where epsilon is nothing but 0 units. So next, this 250 is not going to be affected because epsilon is equal to 0. Now if you look at what is the next minimum cost minimum cell, so the next minimum cell is 9. So for which we have the requirement at D3 200 units, and here we have 250 minus 200, so we'll have an availability of 50 units. Now we have another, that is the only one cell left, that is this cell, that's from W1 to D6, where we have an availability of 50 units and requirement of 50 units. Therefore, we transport from W1 to D6 50 units. So thus, if you look at all the rows and the columns, we have exhausted. So if you write this neatly in the next matrix, we'll be able to see these allotments. I have circled this particular allotments. That means to say, now from W1 to D1, epsilon units are transported. From W1 to D3, 200 units are transported. W1 to D6, 50 units are transported. And the cost of the transportation per unit is also known. Now when we have this particular data, we calculate the cost of transportation. Even before the cost of transportation, we had to find out whether this solution what we got is a basic feasible solution or not. So we calculate the number of rows. In this case, the number of rows is equal to 4 and m is equal to the number of columns, that is equal to 6. So n plus m minus 1, that is 4 plus 6 minus 1 is equal to 9. If you look at the number of allotments made is also 9. So when n plus m minus 1 is equal to the number of allotments, we say that we have a basic feasible solution. So we are now getting the basic feasible solution, for which we calculate the basic feasible cost. Now how do we calculate the basic feasible cost? From the table, whatever the moments are there, the number of units are transported. From W1 to D1, epsilon units, the cost of 9, you will get 0. From W1 to D3, 200 units are shipped, so the cost of transportation per unit is 9, therefore it's 1800. So similar fashion, we calculate the total cost, and the total cost turns out to be 4900.
Thank you for watching. Please subscribe to MSEC channel.